So let's solve the problem which is called Jump Game Tree from LeetCode using BFS algorithm. So according to the problem description, we have array of integer numbers and we have start index. And each step we can do the following two actions. From index I, we can jump to the index which is equal to I plus array I. Also, we can jump from index I to I minus array I. And if after such jumps, if we will be able to reach the index which value is equal to 0, we have to return true. Otherwise, we have to return false. So the main idea to reach the value of array which is equal to 0. So let's consider such kind of example. So let's say we are right now currently the start index is 5. So from 5 we have to reach 0. So initially we are here. So from 5 we can jump to two places, which is 5 plus 1, which is 6, and the 5 minus 1, which is 4. But these two values are not equal to 0. So from 4 we can jump to 1. 4 minus 3 is 1. Again, this value is not equal to 0, then which means we have to continue. From here we can jump 1 plus 2, which is 3. So we reached the value of array which is equal to 0. So that's why we have to return true. So in order to solve, let's apply BFS algorithm. So as usual, we'll declare empty queue and we have to add start index, which is, for example, 5 in our case, to the queue. Then we have to look to the frontal element. And if the frontal element is equal, if the index at frontal element is equal to 0, then we have to return true. Otherwise, we have to check two conditions. If array at f plus f is less than array size, then we have to add it to the queue. And the second case is f minus array at f more or equal than 0, then we have to again add it to our queue. And we have to pop the frontal element. So we have to keep doing such kind of so many number of iterations, and let's have some kind of threshold, 10 power of 6. And after 10 power of 6 iterations, we will not be able to find such kind of value which is equal to 0. We can just return false. So if we apply this algorithm to this case, let's look what we'll be having. So initially we'll be adding 5. Then from 5 we can jump to 6, which is 5 plus 1. And we can jump to 4, which is 5 minus 1. So we add 6 and 4. We remove 5. So we look to the frontal element, which is 6. From 6 we can jump only to 6 minus 2, which is 4. We cannot jump to 6 plus 2, which is 8, which is more than length of the array. So we remove 6 and add 4 here. So we look to the frontal element, which is 4. From 4 we can jump to 4 minus 3, which is 1. We cannot jump to 4 plus 3, which is 7, which is more than length of the array. So we add 1. And again look to the frontal element. We remove this one and look to the frontal element. Again from 4 we can jump to 1. So we add it here and we remove this element. So frontal element is 1. From 1 we can jump to 3. 1 plus 2, which is 3. So we add 3 here and we remove this element. We look again to the frontal element, which is 1. From 1 we again can jump to the 3 and we remove this element. So we look to the frontal element and the array at 3 is equal to 0. So we found the element of the array which is equal to 0. And we can continue such kind of iteration so many times. Let's say in our case 10 power of 6 times. If you will not be able to find, then we just can return false.